In Cycle 4, we're going to look at some applications of all the different types of functions that we've been working with throughout the course. In this lesson, we're going to look at some applications of polynomial functions, and then, well, one application, one word problem, and then one of rational functions. And then, of course, some practice on both of those. So we're starting off with polynomials. Solving a problem by determining the roots of a polynomial equation. So it's all going to be algebraic still in these lessons, and but we're going to use algebra to rearrange, isolate variables, and then sort of draw together a lot of the stuff that we've been talking about in the course. The volume in cubic centimeters of a block of ice the sculpture uses to carve the wings of a dragon can be modeled by the function v at x equals 9x cubed plus 60x squared plus 249x, where x represents the thickness of the block in centimeters. There's our other variable. So we got volume versus thickness. What maximum thickness of wings can be carved from a block of ice with volume 2,532 centimeters? So we got a nice story attached to this. If we strip away the story, though, what we're boiling down to is, if I've got a certain volume, what thickness would go along? Well, I've got a particular volume, which in this case is 2,532. What is the thickness that would go along with that based on the formula we have? So they're giving us v of x. They're giving us the volume here. We have to solve it for x. So if we take the formula, plug in the volume of 2,532, and then put the rest of the formula in. What we want to do is we want to solve this. And we've learned that solving a polynomial involves factoring, bringing in things like factor theorem and long division or synthetic division, and the roots and all of that good stuff. So first we want to rearrange it, put it in a standard form. So bringing that 2,532 over to the right, it becomes a negative. And then the first thing I should always do when I'm working with simplifying a polynomial, or any kind of equation really, is always a good idea to look for a common factor. And in this case, I do see one. It looks like everything is going to be divisible by 3. So if I take out 3 as a common factor, while not absolutely necessary, it just gives me smaller numbers, and that's always something that's always desirable, let's say, because working with smaller numbers keeps my calculations a little bit easier. So I want to factor this. The 3 out front is not really involved in our solution anymore. It's obviously part of the overall formula, but it doesn't come into play when trying to solve for x. So using the factor theorem, if I want to use factors of 844, my constant term, which I haven't listed them all, but I am pretty sure is going to involve quite a few different numbers. If I try f at 1, then remember what we do is we just plug in our number, and so I would put 1 into the formula. And so I do 3 times 1 squared, or 1 cubed, which is just 3, plus 20 times 1 squared, so just plus 20, plus 83 times 1, minus 844, and negative 738. So clearly that is not equal to 0. And just to save us a little bit of time, we could also try -1, but that one's not going to work. I already know that I've worked that one out. It's going to be negative 910. And 2 would definitely go into 844, so I could try positive 2, but I don't think that one works, or negative 2 doesn't work. Let's see, 844, can I divide that by 3? No, that doesn't go in evenly, so I can skip over 3, but I can divide that by 4. Yeah, 4 goes in there, right? So I can try 4 as a factor. So if I try f at 4, then I have 3 times 4 cubed plus 20 times 4 squared plus 83 times 4 minus 844, and that one does equal 0. Okay, so didn't take too much effort, especially since I skipped over the 2's, but yeah, even working with the plus and minus 2, it wouldn't have taken a long time to realize that f at 4 works, so x minus 4 is a factor. And then we can go to work with our solving, our dividing. So using synthetic division, which is totally legitimate because I'm using a linear divisor, I would have 4, and I would use my coefficients of 3, 20, 83, and negative 844. And bringing down the 3 gives me 3 times 4 is 12, plus 20 is 32, times 4 is 128, added 83 gives me 211, times 4 is 844, plus negative 844 is 0, and that's what I wanted to see. I wanted to see that we got a remainder of 0. So I now know that if I was to think of that as my rough work, and if I wanted to go to my next stage from this line, I'd know that 0 equals 3 times x minus 4, which was this factor here, times 3x squared, plus 32x plus 211. And of course, now I need to try and factor that, if possible. Let's check first to see if it's possible. Let's use the discriminant. So b squared minus 4ac, before we spend a lot of time trying to factor this, is equal to 32 squared minus 4 times 3 times 211. Negative 1,508. Which tells me there's no solutions to this quadratic here. No. Right? There's no solutions to that quadratic, putting in those a, b, and c values. So there's no other possible values of x. That means simply that x equals 4 is the only possible solution. And so the wings can be 4 centimeters thick. Let's move on. Let's take a look at an example of a rational word problem. The acceleration due to gravity is inversely proportional to the square of the distance from the center of the Earth. The acceleration due to gravity for a satellite orbiting 7,000 kilometers above the Earth is 8.2 meters per second. Write a formula for this relationship. So the relationship is acceleration compared to distance in fact, the square of the distance. And so if we use A for acceleration and D for distance, we need to pay attention to the fact that we have units of 7,000 kilometers and we have an acceleration of 8.2 meters per second. So we can't have these different units. So why don't we change this to 7 million meters so that we have the same units. Now, if I want to write a formula for this relationship, the assumption is there's some sort of constant involved, and we have to figure out what that constant is. So, for A part, writing the formula, it's going to be the acceleration, as it says, I'm going back to the first sentence, acceleration is inversely proportional to the square of the distance. So it's something over the distance squared. And again, there's a constant involved. So I need to know, I have to figure out what the constant is, right? I have to find K so that I can complete the formula. That's where 8.2 can be placed in for A, and 7 million can be placed in for D. I don't need brackets, but I do need to square it. And I have to isolate K. So if I multiply both sides by 7 million squared, I'll get K by itself, and I'll have 8.2 times 7 million squared. So 4.018 times 10 to the exponent 14 is how we can read that. So to finish off the formula, what we have is, let's write it over here so I can save a bit of space at the bottom. A equals 4.018 times 10 to the 14 all over 7 million, not 7 million, that was a specific value, wasn't it? All over D squared. B part, though it's called C here, let's call it B, that bugs me, to go from A to C. There we go. B part, at what height will the acceleration due to gravity be 6 meters per second? So we're being given an A value, right? So that means I just need to plug in, what was it again? 6.0, but I don't need to write the decimal out. 6 in for A and find out what D is. So again, rearranging, that means I'm going to get D squared by itself. I'm going to have 4.018 times 10 to the 14 over 6. And if I take the square root of each side, that'll get rid of the squared on the left. So I still have that 4.10 times 10 to the 14 on my calculator. If I just divide it by 6, take the square root, and I get 8,183,316. What are the units? They're meters. So since we're dealing with space and large distances, maybe it'd be more appropriate to now switch back to kilometers. So if I divide by 1,000, it's approximately equal to 8,183 kilometers at a height of 8,000, I keep saying the wrong thing, 8,183 kilometers. we're going to have an acceleration of 6 meters per second. So, practice questions, yes. Good, useful tying it all together for polynomials and rational